Okay, everyone. So we have a problem from 2022 AMC 8 number 17. Okay, so let's read the question first. So we have a factorial problem, but at the same time, this is not usual factorial question. So it's a double factorial notation, so which is something you probably never seen this before. But it's just actually telling you the definition of that. So which is why you don't really need to have some concern about this, because they already telling you what is that look like, or what is that supposed to mean. Okay. So anyway, so if you are not really familiar with the factory itself, it's just a like kind of neat way of writing product of a bunch of integers starting from one. Okay. So for example, if you have like 2 factorial, that means that's just product of the 1 and 2. And if I have 5 factorial, so that will be the product of the first 5 integers. So again, that's just the definition of the factorial. That's how we just write it in a, I guess, neat way instead of writing like 5 factorial. So again, if you have like 100 factorial, so you don't really want to write all those 100 integers to multiply, which is going to be a bit tedious, I guess. And you can just say this is going to be 98, and you can just multiply all these integers. Anyway, that is factorial, but in our problem, it's just actually telling us it's double factorial, not just the factorial, right? So it says if n is an even positive integer, double factorial notation represent the product of all even integer from 2 to given number n. So for example, 8 double factorial is 2 times 4 times 6 times 8, and that's the 8 double factorial. And based on that, what is the unit digit of this sum? Okay, so it looks like there are too many numbers that we need to take care, but as you will see, it will not actually going to be that many. Okay, so but if you are not sure what to do, if you're like seeing a question that looks like too long, then it's maybe easier to deal with some small case and experiment and see how that looks like. Okay, which is I'm going to do that as well. So the first one, 2. By the way, unit digit is just the last digit when you add all these numbers. Okay, some people may not know about that, but anyway, so 2 double factorial is just 2, because we have like our definition was saying multiply all the even integer from 2 to n. Since our n is also 2, so that means just a 2 double factorial just 2, and 4 double factorial is going to be 4 times 2, which is going to be 8. Okay, and then 6 double factorial will be 6 times 4 times 2. At the same time, just keep in mind, like when you are adding numbers to find the unit digit, you are adding actually just the unit digit, each of those numbers that you are adding. You are just adding the unit digit of each of those numbers to get the unit digit of the sum. So what I mean by that, let's say you have like 47, 28, like 14, a bunch of some like other numbers. If you are trying to find a unit digit, you are just adding these guys to get the unit digit, right? So which is why you don't really care about the tens digit, hundreds digit, whatever other like digit that you have. So we just need to take care of the unit digit, because that's gonna give us the unit digit of the sum as well. So for this guy, like if you wanna multiply this, that's okay, which is not too bad. But the multiply those 8 by 6, which is 48. But I don't really want to take the 48 because I just care about the unit digit. So unit digit of this guy was just 2. Unit digit of this guy is 8. But the unit digit of this guy is also 8. Okay. And then I can see this in a different way. I'm just telling this because that will be a bit easier for larger values that you don't really need to multiply. Okay. So for example, if I say 6 times 4 is 24, okay, my last digit is 4, so I need to multiply that last digit by 2, which is 8. So you can get that immediately just taking the last digit of each product, which is gonna be a bit easier when this number is actually getting bigger and bigger. But let's take the 10. Okay, so that would be 10, 8, 6, 4, and 2. Okay, so let me see, 6, 4, and 2, right? Okay, I think I'm gonna do the 8 as well. I just skipped that. Anyway, so if I do the 8 first, maybe 8 double factorial is 8 times 6 times 4 times 2, right? So as you see, there are 4 numbers, and now we just need to get as soon as possible. Okay, so we don't want to waste just multiplying those numbers. We can just see 8 times 6 is 48, right? And then last digit of this product is 8. So I can take that last digit, which is 8, multiply by maybe 4, which is 8 times 4 is 32. Last digit of those 3 product is going to be 2, because 32 has 2 at the end. And I can multiply that 2 by this 2, which is going to be 4. So that means my last digit of this product is going to be 4. Again, you don't really need to multiply those. I'm just multiply any 2 numbers that I feel like to multiply, and I get the last digit of that product, and then I multiply that last digit by another integer that I have in my list to get my last digit of the next product, and then I just keep doing this until I get my all numbers to multiply to get my last digit. So if you don't feel that's correct, then you can just go ahead and multiply and see if that's really the case, okay? But I'm gonna do the same thing with this guy. But if you look at this, whatever you multiply right here, so you will get a digit at the end from this for integer, but you're gonna multiply that guy by 10, which is gonna give you some numbers with 0 at the end. So that means my last digit of 10 double factorial will be 0. And it will be the same thing for anything higher than that. So for example, if you have 12 factorial, double factorial, okay, so you will get 12 times 10 times 8 times 6 times 4 times 2. So regardless of what you get as your last digit, when you multiply everything other than this number, then you're going to get a last digit, but you're going to multiply that number by 10. So your last digit will be 0 anyway. So regardless of what you have, since you have a 10 in that product, your last digit will be always a 0 for anything that is 10 double factorial or higher than that. So which is why we don't really care the numbers like these, because all of these numbers will have at least 1 0, because you will have a 10 in that product at least once. Okay, so only thing that we need to take into consideration is the first numbers, like which is 2 double factorial, full double factorial was 8, and then 6 was also 8, and then 8 was 4, and then 10 is 0, and 12 is 0, and everything else is gonna be just 0. Okay, so if you just add those, you just see that only thing will affect our sum is gonna be the first numbers. So that's 10, which is 12, 22. So my last digit is, I guess, just this number. Okay, so I hope that makes sense. So it's finding the last digit is actually one of the good questions that you might see. This is one of those. Okay.